Here, the important topics we have is line spectra. Here, the topics which we have is line spectra. Here, the topics which we have line spectra, Bohr's theory, Sommerfeld theory, energy levels, and vector atomic model, and Frank Hertz experiment. So, total 1, 2, 3, 4, 5, 6. Here we have total 6 topics to cover from this unit. Out of 6 topics, first we will see before that we will see the introduction part. In introduction part, energy distribution, we'll see in the introduction class, continuous energy distribution of black body radiation using classical theory is continuous energy distribution of continuous spectrum of energy distribution using a black body is not explained by the classical theory. What is the meaning? Classical theory is not explain the black body radiation continuous spectrum. Then who is explained this continuous spectrum of the black body radiation? The continuous spectrum of black body radiation is explained by the Max Planck. Max Planck explained this one. So here what we are seeing, taking hydrogen atom, after getting the spectral lines across the output, we are observing the distance between the wavelengths of the spectrum. Suppose I am getting this spectrum. What is the distance between these two lines in the output of the spectrum? That is studied by whom? Bohr studied this one. Bohr in 1913 proposed a theory of atomic structure, and he determined the spectral lines of the atomic structure. These are the things we are seeing in the introduction. Next, our topic is line spectra. Actually, what is this one line spectra? Here we are checking. I am taking a source and a slit. Through this slit, in the monoatomic gas. Here, what we have here, it is in the electron discharge tube. Whatever the tube I am taking, electronic discharge tube. Here, monoatomic gas is there. So the rays are passing from here. The source consists of electric discharge passes through monoatomic gas in the door. So atoms has passed with this slit. This slit nunchi pass avutundi. After passing the slit, it is phased to the prism. Prism కి అటాచ్ అయ్యింది. ఈ ప్రిజం నుంచి మనకి రేస్ వస్తున్నాయి. వాట్ ఎవర్ ద అవుట్పుట్ ఆఫ్ ద రేస్ ఇస్ కలెక్టెడ్ ఆన్ ద ఫోటోగ్రాఫిక్ ప్లేట్. It is collected on the photographic plate. What is the view in this photographic plate? The view in this photographic plate is we are getting the spectrum with different wavelengths. First line in the spectrum, the second line in the spectrum, the third line in the spectrum. As we are going, the lines are very near compared to the beginning point. This is about the line spectra. You have to draw the diagram and explain its functioning. Again, I am repeating. I am taking a discharge tube. What I am taking? Taking a discharge tube. So, a tube is there. Tube is called as discharge tube. Across this tube, there is a mercury gas inside the tube. I'm taking a source element to source whatever the energy passed from here, source to, it is passes from the split. After split, again it is passed to the prism. Again from prism, it is splitting. This splitting is collected across where? This split is collected across photographic plate. The view of photographic plate is this one. The first line in the spectrum, I am calling this as H alpha. The second line in spectrum is calling as H beta. The third line in the spectrum is calling as H gamma. As we are moving, the lines are very close compared to the beginning point. This is the explanation of the line spectrum. You see, afterwards, after description of the diagram, Lewing and Dewar in 1980 observed similarities in the spectrum of alkali. Same similarities we are observing even in the alkali metals. Successive pairs in the lines in the spectrum of sodium is alternatively sharp and very diffuse and very close to together as we are moving to shorter wavelengths. What is the meaning of shorter wavelengths? Here the wavelength is maximum. What is the meaning of shorter wavelength? What is the wavelength here? Here the wavelength is 6562. Here the wavelength is 4500. Here the wavelength is 4300. So as we are moving, the wavelength is decreasing. Across the shorter wavelength, the spectrum lines are very near with each other. Across the longer wavelength, there is a gap between the spectrum lines, whereas coming up for the shorter wavelength, the spectrum are very close to each other. This is about the line spectrum. After drawing this diagram, wavelength formula lambda equal to 3046 n square by n square minus 4, which it is measured, is in terms of angstroms we are measuring. Angstrom we are measuring. Suppose if n equal to 3, what it means, whatever the spectrum line we have, it is called H alpha. If n equal to 4, whatever the spectrum line, it is H beta. If n equal to 5, whatever the spectrum line is there, this is gamma. To this one, the Balmer formula is given. The reciprocal of wavelength equal to represented with K. What is the formula? Rydberg constant R with hydrogen atom. For hydrogen atom, Rydberg constant by 1 minus 2 square minus 1 by n square. In the next Bohr atomic model, there I will explain this one, how we got this equation. Here where n, what is n value? Where n value equal to 3, 4, 5. So if you ask, if you are getting question about line spectra, what are the things to cover? If you get a question of line spectra. Suppose line spectra is question is K means description of the diagram. Next is shorter wavelengths, more near lines is observed. Next, angstrom, it is measured in angstrom. Next, this spectral series diagram and formula has to write for this answer. Next topic is Bohr theory. In Bohr theory, what are the third topic? Third topic is Bohr theory. What are the things we have to cover in Bohr theory? Niels Bohr introduced this Bohr theory of the hydrogen atom. In his theory, he explained about the Balmer series of hydrogen atom and he's given 4 postulates. How many postulates he's explained? He's explained 4 postulates. What are the first postulate? The first postulate is here in the atom, there is an electron. Suppose here electron is there. Here nucleus is there. So the force of attraction between nucleus and electron is, which force of attraction is there? There is Coulomb force of attraction is there. There is Coulomb force of attraction. Then what the Coulomb force of attraction is? There is a Coulomb force of attraction between the nucleus and electron. This is the first point. Second point is the angular momentum L equal to h by 2 pi. The angular momentum h equal to orbital angular momentum is integral multiple of h by 2 pi, where h is the constant. Next, as electron is moving around it, it is not radiating any electromagnetic radiation. If not emitting any electromagnetic radiation, not emitting, electromagnetic radiation is not emitting. If electromagnetic radiation not emitting, energy is constant. Energy is constant. So Those orbits is called as stationary orbits. Here, energy is remains constant. Orbits are stable. So this ground state and again, we will record these postulates and we'll go for it. Between the electron and nucleus, there is the Coulomb force is there between the electron and nucleus. What is the second? 2 pi. As electron is moving constant, there is electromagnetic energy is not radiating. Not electromagnetic energy is not radiating. Let's go. Right. Writing cursor point. And what? What are the four postulates we discussed? What are the four postulates discussed? First postulate is middle లో మనకి nucleus. ఇక్కడ electron. What is the force between these two? The force between these two is Coulomb force. Coulomb force is there between those two. What is the second point? Second is orbital angular momentum equal to h by 2 pi. Third one is when electron is moving around a orbit, electron is revolving around, it is not emitting. It is not emitting any electromagnetic radiation. Electromagnetic radiation emits cheyatledu. It is not emitting electromagnetic radiation. Fourth one is difference is energies. EF minus E initial by H. EF minus E initial by H. These are the four postulates. Based on these four postulates, now we will see the derivation part. What I am calculating in the derivation part is, I will calculate velocity, I will calculate R. Again, I will calculate total energy. Total energy is a combination of potential energy plus kinetic energy. Then I will calculate the frequency. These are the four parameters we will calculate in the derivation part. These are the four parameters. Velocity I will calculate. I will calculate radius. I will calculate total energy means this is potential energy calculation plus kinetic energy calculation. Total energy I am calculating. After calculating total energy, I will calculate what? Frequency. So this is very, very, very important 10 marks question. Now we will see the derivation part. In the derivation part, what we have in the derivation first? We have two types of force. Coulomb force is equal to centrifugal force. Coulomb force equal to centrifugal force. What is Coulomb force? K naught Z E square by R square is equal to MV square by R. ఈ R ఇక్కడ R పోతుంది. So what we got? K naught Z E square equal to MV square. Take this as equation number 1. Equation number 1. After that, here, what is K naught? K naught is permittivity of free space. Permittivity of K naught is permittivity of free space. Suppose if I am considering L is, what is L? Orbital angular momentum. If L is orbital angular momentum, then we have L formula. L equal to, I am taking MVR is equal to NH by 2 pi. MVR equal to NH by 2 pi, which also can write MVR equal to NH dash, where H dash equal to, what is H dash? H by 2 pi. This is the first part of the derivation. From here, I am calculating V value. From here, I am calculating V value. So, what we have? MVR equal to NH dash. From here, I am calculating V. V equal to NH dash by MR. This is equation number 3. Substitute 3. 1. 3 ని తీసుకొచ్చి 1 లో A ప్లస్ లో పెట్టాలి, V ప్లస్ లో పెట్టాలి. వాట్ ఈస్ 1? K naught ZE square by MV square ఉంది కదా, అందులో ఇక్కడ 3 లో ఉన్న V ని తీసుకొచ్చి ఇందులో సబ్స్టిట్యూట్ చేయాలి. సో వాట్ వి విల్ గెట్? K naught ZE square is equal to M times of N H dash by MR whole square. So మనకి ఏమొస్తుంది? After simplification, K naught Z E square is equals to M N square H dash square by M square R square. M square R square. V కూడా ఉంది కదా ఇక్కడ. KZ E square MV square కదా. So K naught Z E square equal to MV square R. ఇక్కడ క్రాస్ మల్టిప్లై చేసినాక ఒక R ఉంటుంది ఇక్కడ ఈక్వేషన్ 1 లో. సో ఇక్కడ ఒక R కూడా ఉంది మనకి. తర్వాత ఏమవుతుంది? M and this square will cancel, this R and this square will cancel. After that, what we are getting? K naught Z E square is equals to N square H dash square. N square H dash square by M times of R. From here, I am writing R equation. From here, I am writing R equation. What is R? R equal to N square H dash square by K naught Z E square M times of. This is very, very important because we will substitute this one in the future further. So equation 4. So in the first part, I calculated V value and R value. We will use these two, V and R, in the future equations. Next, now I will come to different radiuses. Suppose n equal to 1. At that time, what we will get? R equal to h dash square by m k naught z e square ఉంది కదా. Substitute h value, m value. Substitute m value, h value, k value, z value, e value. Suppose h equal to 6.625 into 10 to the power of minus 34. M value I am substituting 9.1 into 10 to the power of minus 31. Next, k naught is equals to 9 into 10 power 9. Suppose charge of the electron I am substituting 1.6 into 10 power of minus 19. If I substitute all these things, I will get R value. What is the R value I will get here after substituting all these? After substituting all these, I am putting R value as R1 value as 5.28 into 10 power of minus 11. This I am getting if n equal to 1. Suppose n equal to 2. If n equal to 2, what we will get? R2 is equals to 4 times of R1. Suppose I am writing n equal to 3. Suppose if I take n equal to 3, what I will get? R3. R3 I will get equal 9 times of R1. So still now up to here we did which calculation? Voltage and R is calculated. From here I calculated, first I wrote postulates. Next, two forces are equal. I calculate voltage value. I calculated R value. For n equal to 1, n equal to 2, n equal to 3, for different R values I did. Next, my part is I will calculate total energy. My next task is calculation of total energy. How to calculate total energy? Here, first I will calculate potential energy. Potential energy equal to V. And voltage formula is V equal to integral of infinity to R K naught Z E square R square times of dr. If I integrate, I will get V equal to minus K naught Z E square by R times of dr. Why I am getting in this way? Integral of 1 by R square dr equal to minus 1 by R. This is one formula. Based on this, I calculated voltage. Next, I am calculating kinetic energy. Potential energy calculation is over. So what we calculated potential energy. Whatever this one I got, this one, this is potential energy calculation. Whatever I calculated this one, this is potential energy calculation. After potential energy calculation, now I am doing kinetic energy calculation. Kinetic energy formula is equals to of mv square. Previous V, whatever I got, previous calculation part I will write here. Previously, I wrote of mv square equal to K naught Z E square by 2R. From where we got this one? From equation 1. What is our equation 1 previously? Here. Of mv square. From here, equation 1. Divide two sides 1 by 2 తో divide చేద్దాం. Divide two sides by 1 by 2. What you will get? 1 by 2 K naught Z E square equal to M V square R by 2. Suppose K naught Z E square by 2 times of R equal to 1 by 2 MV square. This part I got from where? From equation 1. I simplified this one from equation 1. This one I am substituting in the down part. This one I wrote here. Now what I am doing? Of mv square equal to this. What is of mv square? Kinetic energy is represented with here T. T equal to K naught Z E square by 2R. Now previous we got radius R. Substitute that radius R here. Previous what we got radius value? Radius value formula ఏముందమ్మా ఇది రేడియస్ వాల్యూ ఇస్ హెచ్ డాష్ స్క్వేర్ ఎంకే నాట్ జెడ్ స్క్వేర్ కానీ మనకు అక్కడ రేడియస్ డినామినేటర్ లో ఉంది కనుక ఈ రేడియస్ ఫార్ములా రెసిప్రోకల్ అవుతుంది. దట్ వన్ ఇస్ సబ్స్టిట్యూటింగ్ రేడియస్ ఫార్ములా. Substituting radius formula. Okay. After simplification, we will substitute. We will substitute after simplification. Next, total energy వచ్చాక radius పెడదాం. ఇప్పుడు చూడండి నెక్స్ట్. Now, total energy I am writing. Total energy E equal to potential energy plus kinetic energy. Potential energy is what? V. Kinetic energy is T. Total energy E equal to V plus T. Substitute that one. What we got? V from equation potential energy. This one we got V. What is V? Minus K naught Z E square minus K naught Z E square by R plus total energy in the chindi. This one total energy T. What we got? K naught Z E square by 2R. Here I am making common K naught Z E square by R. If I make common, what I will get? 1 by 2 minus 1. So I will get minus after K naught Z E square by 2R. So we calculated energy formula. Now in this energy formula, I will substitute radius formula. Take this one as equation number. Take this one as equation 7. What is 6 and what is? Now I'm substituting radius formula. What is our radius formula? In here, in energy equation, radius is in the denominator. So what is energy formula? E equal to minus K naught Z E square by 2R. I'm substituting value from equation 4. Radius previously calculated, I am substituting here. Minus K naught Z E square by 2 times of R. If I substitute R, what is R? M naught K naught Z E square by N square H dash square. After substituting, you will get E as minus M naught K naught square Z square E to the power of 4 by 2 times of N square H dash square. This is the equation of what energy? This is the equation of energy. In this energy equation, I am taking this as E equal to minus of R by N square, where what is R? Where R is Rydberg constant. What is R? R is Rydberg constant. Where what is R value? R value is equals to minus M naught K naught Z square e to the power of 4 by 2 times of H dash square. So this is the value of R. This is the value of R. Where R equal to, what is the, we will get 2.179 into 10 to the power of minus 18 joules. Suppose N equal to 1. What is our formula? What is our formula? We got E equation, we got. What is our formula? E equal to minus R by N square. If N equal to 1, then our radiation E equal to how much we will get? Minus 13.6 electric volt. Next, what is our task? So here, what are the things I calculated? Velocity calculated, radius calculated, potential energy is calculated. Next, kinetic energy is calculated. Next, total energy E equal to V plus T calculated. We got total energy equal to R by N square. All these are over. Next, I want to calculate frequency. Next, by calculating frequency, this topic will be covered. Next part is frequency calculation. In frequency calculation, frequency formula equal to energy of final state minus energy of initial state by H. Energy of final state minus energy of initial state by H. Or first initial, next planet. Formula of energy E equal to frequency formula, energy of initial state, ground state, energy of final state by H. Next, I'm calculating. In place of N, once I will substitute initial statements Ni, final statements Nf. Based on this, now I am writing equation. What is our equation? E equal to EI. EI means energy formula. M times of Z square e to the power of 4 K naught square by 2 times of H dash square Ni square. Minus of minus plus M z square e to the power of 4 k naught square by 2 h dash square nf square. From here, make common. From here, a equal to minus m z square e to the power of 4 k naught square by h కూడా ఉంది కదా మనకి. వాట్ ఈస్ ఎనర్జీ ఫార్ములా? h ఉంది డినామినేటర్, సో మనకి ఇక్కడ h కూడా వస్తుంది. డినామినేటర్ h అనే టర్మ్ ఉంది కనుక, సో ఇక్కడ ఏముంది 2 h డాష్ స్క్వేర్ డాట్ h కామన్ చేస్తే ఇక్కడ మనకి 1 by n I స్క్వేర్ మైనస్ 1 by n of f స్క్వేర్. ఇది మన ఈక్వేషన్. సో ది హోల్ టర్మ్ ని నేను ఒక కాన్స్టెంట్ ఈ అనుకుంటున్నాను. సో ఈ ఈక్వల్ టు Redberg constant R infinity times of equation of minus ఉంది కదా, small correction in this. So making plus here, this is n of f square minus n of I square. Positive Jesus by 1 by n of f square minus 1 of n of I square. ఈ వాల్యూ వచ్చేసి వేర్ సి కూడా ఉంది కదా మనకి ఇక్కడ, లేదు సి ఎనర్జీ వచ్చేసి. సో వి గాట్ దిస్ ఇస్ నాట్ ఎనర్జీ, దిస్ ఇస్ వాట్ ఫ్రీక్వెన్సీ. Whatever I calculated is not lambda, that is frequency. Whatever I calculated is frequency calculation. Whatever is calculated is frequency calculation. Now, based on frequency calculation, continuation, based on frequency calculation, now I am considering a constant k is equals to frequency by velocity, which equal to 1 by lambda is equals to r infinity times of z square separate rational z square times of 1 by nf square minus 1 by ni square, where r infinity is equals to మన మొత్తం కాన్స్టెంట్స్ అన్నమాట, where r infinity equal to m e to the power of 4 k naught square k naught square to the power of 4 k naught m e to the power of k naught square by 2 times of h times of h dash square times of c. If h dash equal to h by 2 pi substitution, to make h dash equal to h by 2 pi, then what we'll get? Then what we'll get? R naught value is different. Then R infinity equal to 2 pi square m e to the power of 4 k naught square by c times of h cube. This R infinity. And total formula is final formula is what is final formula? Final formula is K. Final formula is K equal to 1 by lambda is equals to R infinity Z square by 1 by NF final state minus 1 by Ni square. Up to here is Bohr atomic model. Up to here, whatever the things we discussed is Bohr atomic model. So first we will just recall what are the things we calculated in Bohr. First we calculated velocity. After calculating velocity, I calculated radius. After calculating radius, I calculated potential energy, which is represented with V. Next, I calculated kinetic energy, which is represented with E. Next, I calculated total energy in terms of E plus V. God. Kinetic energy is T. Kinetic energy equal to T. Next, total energy E equal to T plus V. After calculating total energy, calculated frequency, nu. After calculating frequency, what we calculated K equal to 1 by lambda equal to this formula we calculated. This is the final equation of what? Bohr atomic model. This is the final equation of Bohr atomic model. Just I will show this one in the slide. Big derivation and it is a 10 marks question. See here, first calculated V. After calculated V, here calculated R, which is equation number 6. P is equation of next potential energy is calculated, which is equation number 5. Next kinetic energy is calculated, which is equation number 6. After calculating potential energy and calculation energy, total energy is calculated. In the total energy equation, we have radius R in the denominator. The denominator value calculated and written total energy equal to R by N square. After calculating energy, then frequency of the emitter radiation is calculated. Frequency of the emitter radiation is after calculation. I'm taking a K. K equal to 1 by lambda and K value is calculated. This is about Bohr atomic theory. In Bohr atomic theory, here I am taking NF equal to 2. This part is left. And discuss one more thing. Here, what is the formula? Final formula we got. The final formula is K equal to 1 by lambda times of R infinity Z square. 1 by Ni square. Suppose if NF equal to 2, what is Ni? Ni equal to 1. 1 value is in less. 1 value is less. Suppose N of F equal to 2. Then N of I equal to 2. 2 ఏముంటది 2, 3, 4, 5 ఉంటుంది. సపోజ్ NF అనేది 2 ఉంది. దెన్ NI ఏముంటుంది? ఒకటి పెరుగుతుంది. 1 is in increasing number. N ఏముంటుంది? 3, 4, 5, 6, 7. Suppose NF అనేది 3 వచ్చింది. నెక్స్ట్ NF అనేది 3 వచ్చింది. అప్పుడు NI ఉంటుంది మనకు 4, 5, 6, 7. Suppose NF value 4 తీసుకున్నాను. నెక్స్ట్ NI value 5, 6, 7 డయాగ్రామ్ లో డ్రా చేసినప్పుడు ఫస్ట్ ఒకటి ఇది ఇన్ఫినిటీ లైన్. నెక్స్ట్ వచ్చే లైన్ ఏమో n ఈక్వల్ టు 7. నెక్స్ట్ వచ్చే లైన్ n ఈక్వల్ టు 6. నెక్స్ట్ వచ్చేది స్లీపింగ్ లైన్స్ తీయాలి యాక్చువల్లీ. హారిజాంటల్ లైన్స్. ఇది n ఈక్వల్ టు ఇన్ఫినిటీ తీసుకోవాలి. ఇది n ఈక్వల్ టు 6 తీసుకోండి. ఇది n ఈక్వల్ టు 5 తీసుకోండి. ఇది n ఈక్వల్ టు 4 తీసుకోండి. ఇది n ఈక్వల్ టు 3. నెక్స్ట్ వచ్చేది n ఈక్వల్ టు 2. నెక్స్ట్ వచ్చేది n ఈక్వల్ టు 2. నెక్స్ట్ వచ్చే లైన్ n ఈక్వల్ టు 1 తీసుకున్నాం. ఇప్పుడు చూడండి, ఇనిషియల్ స్టేట్, ఫైనల్ స్టేట్. సపోజ్ n ఈక్వల్ టు 1 దగ్గర ఉన్నాం. n ఈక్వల్ టు 1 ఉన్నప్పుడు ఎక్కడి నుంచి వచ్చి పడతాయి? ఇప్పుడు రేస్ ఫాలింగ్ ఎక్కడి నుంచి ఉంటుంది? రేడియేషన్ ఎమిటింగ్ ఎక్కడి నుంచి అవుతుంది? n ఈక్వల్ 2 నుంచి ఎమిట్ అవుతుంది, n3 నుంచి ఎమిట్ అవుతుంది, n4 నుంచి ఎమిట్ అవుతుంది, n5 నుంచి ఎమిట్ అవుతుంది, n6 నుంచి ఎమిట్ అవుతుంది. నెక్స్ట్ n ఇన్ఫినిటీ లైన్ నుంచి ఎమిట్ అవుతుంది. ఇన్ఫినిటీ లైన్ నుంచి ఎమిట్ అవుతుంది. నెక్స్ట్ n2 సెట్ చేద్దాం. n ఈక్వల్ టు 2 ఉన్నప్పుడు n ఈక్వల్ టు 2 ఎక్కడ నుంచి పడుతుంది? 3 నుంచి ఫాలో అవుతుంది, 4 నుంచి ఫాలో అవుతుంది, 5 నుంచి ఫాలో అవుతుంది, 6 నుంచి ఫాలో అవుతుంది, 7 నుంచి ఫాలో అవుతుంది. నెక్స్ట్ 3కి వచ్చేస్తే 3కి ఎక్కడి నుంచి వస్తుంది సెట్? 3కి 4 నుంచి, 5 నుంచి, 6 నుంచి, సిమిలర్లీ ఇన్ఫినిటీ నుంచి. నెక్స్ట్ 4కి 5 నుంచి లైన్ వస్తుంది, 6 నుంచి వస్తుంది, ఇన్ఫినిటీ నుంచి వస్తుంది. నెక్స్ట్ 5కి 6 నుంచి వస్తుంది, ఇన్ఫినిటీ నుంచి వస్తుంది. ఇప్పుడు సెట్ ఆఫ్ లైన్స్ ఫామ్ అయ్యాక ఫస్ట్ set of series of lines is called as Lyman series. Next set of lines is called as Balmer. P-A-L-M-E-R, Lyman Balmer. Next one వచ్చేది Paschen. నెక్స్ట్ వచ్చే సెట్ ఆఫ్ లైన్స్ బ్రాకెట్. నెక్స్ట్ వచ్చేది ఫండ్. సో మనకి స్పెక్ట్రల్ సిరీస్ ఫామ్ అవుతుంది. వాట్ ఆర్ ద స్పెక్ట్రల్ సిరీస్ నేమ్స్ వి హ్యావ్? ద నేమ్స్ ఆఫ్ ద స్పెక్ట్రల్ సిరీస్ వి హ్యావ్ Lyman series, Balmer series, next one Paschen series, next one is bracket series, next one is fund series. All these are spectral series which are formed in Bohr atomic model. So up to here we completed Bohr atomic model, which is very, very important question. Next one we have Sommerfeld theory. Next topic is Sommerfeld theory. Here we have two postulates in Sommerfeld theory. What is the first postulate? There in a Bohr's atomic model, electron around the nucleus is circular shape. This is nucleus, this is electron, which it is evolving in circular shape, whereas here it evolves in elliptical shape. This elliptical. First one is in elliptical shape. Second one is velocity changes. If velocity changes, mass changes. If mass changing, what is mass equation? M naught by under root of 1 minus v square by c square. This is called relativistic mass formula. This is second point. The first point is based on this, we'll see derivation part. Is the quantum conditions. For the quantum condition. Equal to. Ma'am, వచ్చిందా? Now we will see Sommerfeld theory, derivation part, integral of P of dr equal to nr times of h. From here, another equation we have integral of P of phi d of phi equal to k of h, where n of r comma k are integers. From this, where NR is radial quantum number, where NR is radial quantum number, and K is azimuthal quantum number. K is azimuthal. K is azimuthal quantum number. And I'm taking N of R plus K equal to N. N of R plus K equal to N. Based on this, integrating equation 1 and 2, we are writing these steps directly, no need of further simplification of these two equations. This is equation number 1. This is equation number 2. Integrating these two equations. Integrating equation 1 and 2. Integrating equation 1 and 2. Final equation, I will get 1 minus epsilon square equal to K square by K plus NR whole square, where epsilon is eccentricity of the ellipse. Eccentricity of the ellipse. From here, I am writing 1 minus epsilon square is equals to K square by R square. Enough. K square by square. If A comma B are integers, if A comma B are two integers, then I am writing 1 minus epsilon square is equal to K square by N square is equal to A square by B square. Which it is equal to 2. Epsilon square equal to B square by A square. Previous equation we got 1 minus epsilon square equal to K square by N square. Equating these two equations, I think these two equations, equating these two equations, what I will get? K square by N square equal to B square by A square. Which implies K by N equal to B by A. K by N equal to B by A. From this, again write energy equation. From here, write energy equation. Okay, what will get energy equation? Energy equation E equal to minus M e to the power of 4 Z square by 8 K naught square or epsilon square. Any term you can use. Permittivity of the free space. K naught square, N square, H square. So the conclusion is the energy equation of Sommerfeld and Bohr is same. Energy equation of Sommerfeld and energy equation of Bohr. Both are same. Both are same. So again, I will give a conclusion of what we discussed in Sommerfeld theory. What we discussed in Sommerfeld theory. Here in Sommerfeld theory, the orbitals are in elliptical shape, whereas in both the orbitals are in circular shape. ఇక్కడ మనకి ఏ షేప్ ఉందమ్మా? ఎలిప్టికల్ షేప్ లో ఉంది. అండ్ యాజ్ ఎలక్ట్రాన్ రివాల్వ్స్ అరౌండ్ ద ఆర్బిట్, ఈ ఎలక్ట్రాన్స్ అనేది ఆర్బిట్ లో రివాల్వ్ అవుతున్నప్పుడు వెలాసిటీ చేంజెస్. ఇఫ్ వెలాసిటీస్ చేంజెస్, మాస్ చేంజెస్. If mass changing, we are calling it as a relativistic mass relation. The relativistic mass relation is m equal to under root of m naught by under root of 1 minus v square by c square. Next, derivation of Sommerfeld theory. In derivation of Sommerfeld, what I took first, I took two equations I took integral of p of r dr equal to nr times of h. Another equation I took integral of p of phi d phi equal to k of h. Again, from these two, I wrote directly after integration one equation in terms of eccentricity. What is that equation? After writing these two equations, I am taking nr plus k equal to 2. What I am taking? N of r plus k is equals to n. And here using this, I simplified further. What I got in the simplification, 1 minus epsilon square equal to 2. What is the equation? 1 minus epsilon square is equals to k square by k plus nr whole square. In this, I wrote k by n equal to b by a. What is the final conclusion from this Sommerfeld theory? K by n equal to b by a, and wrote energy equations. So this is the derivation part of Sommerfeld theory. ఇక్కడ వరకు రాయాలి. ఫస్ట్ 2 postulates రాయాలి, డెరివేషన్ పార్ట్ రాసి ఎనర్జీ ఈక్వేషన్ వరకు రాస్తే చాలు. నెక్స్ట్ టాపిక్ we have, I will stop with the small topic. Our next topic is 1.5. What is the topic? Energy levels of hydrogen atom. Next topic is energy levels of hydrogen atom. What are the energy levels we have? In energy levels of hydrogen atom, the possible energy states we have. These possible energy states with diagram I will finish. What are the possible energy states we have? The possible energy states are from 332, 22, 332, 21, next 322, 22, 31 level నుంచి 21 level ki, next 632, next 31 నుంచి 22 ki, 31 నుంచి 21 ki. ఇప్పుడు డ్రా చేయాలి. ఎనర్జీ లెవెల్స్ డ్రా చేయాలి. ఫస్ట్ 3 లైన్స్ తీసుకోండి. టైమ్స్ 33, 32, 31. నెక్స్ట్ లైన్స్ ఏమున్నాయి? 22, 21. ఇందులో ఓన్లీ 3 ఆర్ అబ్జర్వ్డ్. వాట్ ఆర్ ద 3 we are observed? 33 నుంచి 22. 33 నుంచి 22 we are observing, and 32 నుంచి 21. 32 నుంచి 21. నెక్స్ట్ ఇంకొకటి 31 నుంచి 22. 31 నుంచి 22. ఓన్లీ అవుట్ ఆఫ్ 6 we are observing only 3. ఆ 3 డ్రా చేయండి. 33 నుంచి 22 వేయండి. ఇంకోటి 32 నుంచి 21 వేయండి. ఇంకొకటి 31 నుంచి 22 వేయండి. ఈ 3 డ్రా చేయండి. మిగతా అన్ని డాటెడ్ లైన్స్ గీయండి. 33 నుంచి 21 ఒక డాటెడ్ లైన్ వచ్చింది. ఇది అయిపోయింది, ఇది అయిపోయింది. 32 నుంచి 22కి, 32 నుంచి 22కి ఒక డాటెడ్ లైన్ వచ్చింది. నెక్స్ట్ 31 నుంచి 21. Here total 6 lines, and that 6 only 3 are visible. Total how many? 6 lines. In this 3 only visible. So this is about energy level diagram of hydrogen atom.